Now, let's just take a look at this example. They say if the probability of A is 0.3, probability of B, as you can see, is 0.4, where A and B are mutual exclusive events. Determine the probability of A and B. So the first one, they need the probability of what? Of A and B. They say that these kinds of two events are what? Are mutually exclusive. And when they are mutually exclusive, what do we know? We know that there's no common intersection there. So it means that the probability of A and B is going to be equal to what? To 0. Going to letter B, what is the probability of A or B? So we know, since it is mutually exclusive, the probability of A or B is equal to what? The probability of A plus the probability of B. Why? Is because this one is equal to 0, so we cannot minus with 0, it's unnecessary. Then we're going to, probability of A is what? Is 0.3 plus the probability of B is 0.4, which is equal to what? 0.7 in total. So going to letter C, which is they need the probability of not A or B. The probability of what? Not A or B. By now, I hope you know this kind of stuff. To find the one that is not, we just have to say 1 minus the probability of what? Of A or B. I've made the video explaining this. Don't worry, you can find it in my description box. So 1 is going to be, what is this one? Is 0.7, which into that are going to get 0.3. So that's it for this question. Let's just take a look at the next one. So the second one says that A and B are mutual exclusive. So this kind of two events are mutual exclusive events with the probability of not A, which is 0.3, and the probability of A or B, which is 0.8. Then the first question is that determine the probability of B. So to find the probability of B, let's just see, we're given the probability of A or B, which is 0.8, and the probability of not A, which we can find the probability of A actually. So first, let's just find the probability of A. The probability of A, this is letter A, is going to be equal to 1 minus the probability of not A. By now, I hope you understand this kind of stuff. I've made a video about it. 1 minus the probability of A is 0.3, which means the probability of A is going to be equal to 0.7, So since this kind of event is mutually exclusive, it means that the probability of A or B is going to be equal to probability of A plus the probability of B, So the probability of A, we just calculated it here. The probability of B, we are looking for it. Probability of A or B, we are given. So this is 0.8 equal to 0.7 plus the probability of B. And then if we take this one to the other side, which is 0.8 minus 0.7, which is equal to probability of B, we're going to find that the probability of B is going to be equal to 0.1, So going to letter B, which is explain why A and B are not complementary, So for an event to be a complementary event, I made a video about this. For an event on a previous video actually, for an event to be a complementary event, what do we have to understand is that for an event to be complementary, it has to be both mutual exclusive and also mutually exhaustive. If we can take a look at this kind of two events, first they are what? It is mutually exclusive, A and B, but is it mutually exhaustive? So these two, if this kind of event, it can be complementary if it has these two, it has both of these. First, it is mutual exclusive, we just confirm it. But is it mutual exhaustive? Let's just take a look at that one. For it to be mutual exhaustive, the probability of A or the probability of B, it has to be equal to what? 1, So let's just take a look at the probability of A or B here. The probability of A or B were given that is equals to what? 0.8. So that means we can conclude that the probability of A, we can conclude that the event A and B are not complementary. Why? Because the probability of A or B is not equal to what? To 1, Yes, it is not equal to 1. You can even show this kind of stuff using a Venn diagram. Actually, you can also show them by using the Venn diagram. You can also draw a Venn diagram whereby you show them these two events. Let's say, okay, it does not have end. Yeah, it does not have end, which means you can show them using a Venn diagram, which is A and B. What is A? A is 0, 0.7. And then what is B? No, A is 0, what? A is 0, yeah. A is 0, 0.7. What is B? B is 0, 0.1, which is that one. And then, yeah, that's it. That's it, actually. And then for the probabilities, it has to be equal to 1, which means there will be something outside, there will be 0, 0.2 outside. Even if you show them by this kind of vendor, they're going to give you full marks. They will see that this kind of is not complementary. Why? It's because it's not exhaustive. Exhaustive, it means it does not have anything outside, and already this one, there's something outside there. So this is the end of this video. See you in my next video. Sharp.